Okay, so BC Calc kids, this is going to look familiar to you because we did learn how to solve this first problem, but we learned how to solve it by solving for the C. Okay, so if you recall, okay, this is review. Okay, what we did was we integrated. So we said, okay, we have some function f of x, which is the integral of 3x squared plus 4x minus 5, right? And then we got x cubed plus 2x squared minus 5x plus c. Then we took this initial condition here and we substituted in. So we said, okay, -1 equals, I'm going to substitute in 2 for the x, 8 plus 8 minus 10 plus c. So 16 minus 10 is 6. Subtract 6 from both sides. -7 is c. Therefore, well, instead of f of x, I guess in the context of this problem, I really should call this y of x, right? So, therefore, y of x, the particular solution is x cubed plus 2x squared minus 5x minus 7. Okay, so now I'm going to show you something called an accumulation function, which is another way to find, okay, so look at what my question is. My question is to find y of 3. So at this point, I would have to substitute in 3. So I'd get 27 plus 2 times 9 minus 15 minus 7, right? So 27 plus 18 is 45, minus 15 is 30, 30 minus 7 is 23, right? So the accumulation function will allow you to find y of 3 without going through all this work. So you could just say, okay, well, y of 3 is a position, right? So you could think to yourself, well, the position at time 3 would be the position at time 2 plus the amount that accumulated from time 2 to 3. Okay, because when we integrate a rate, we get an amount. Remember that. Okay, when we integrate a rate, we get an amount. Okay, so this is going to work equally as well, perhaps better, depending on your opinion. So I have y of 2 is -1, so y of 3 is -1 plus x cubed plus 2x squared minus 5x from 2 to 3. So that's -1 plus 27 plus 2 times 9, 18, minus 15, minus the quantity 8 plus 8 minus 10. Okay, so that gives us -1 plus 30 minus 6. And that ends up being 23. So this is the way we're going to be doing these problems, using an accumulation function. So let's look at example 2. Okay, example 2, we're going to be using a calculator for, so pause the video and go get out your calculator. Okay, so to find f of 1, okay, I have to think backwards here. So to find f of 1, I would have to take off the amount that accumulates. So f of 1, think about it, would be f of 2 minus the amount that accumulated from time 1 to time 2 of sine x squared dx. Okay, so bring your calculators to class because I will be showing you how to do this. So f of 1 is -5 minus this integral, and I will be showing you how to type this in class. Okay? Okay, so if you have the TI-84 or the TI-89, you have to go to mode radian. Okay, for calculus, we're always in radian mode. If you're on the TI-84, you're going to go to Math 9, and you'll be able to type in the integral. But first type -5 minus, and then you'll be able to type this in. Okay, I'll help you in class. So please remind me to do that. So f of 1 is -5.4945. So your final answer would be -5.495 or -5.494. Both answers are accepted on the AP exam. Okay, you can either round or truncate. This is called truncating. Don't even know if you guys know what that means. It just means chopping it off. Okay? Okay, so now you're just going to see different ways that the questions can be worded. They can ask you it graphically. So in this picture in example 3, they're asking us to find f of 0, f of 2, f of 6. So, okay, keep in mind this is the amount from at -2. Okay, so that's the starting amount. So f of 0 would be the amount at -2 plus the amount that accumulates over the time from -2 to 0 of f prime, okay, dx. So you have to find the area, okay, underneath the curve here. So I have, first off, my initial condition is 5, and the area from -2 to 0, you can see the height is 1, 2, 3, 4. 4 times 2 times a half is just 4. So this is 9. And it makes sense because you're accumulating here, because the area is 4, but so is the integral, because you're traveling from left to right and you're above the curve. So now for f of 2, do yourself a favor, use f of 0 now, since you have that, plus 0 to time 2, f prime dx. So we already know that this was 9, right? And then from 0 to 2, you could see by symmetry that that area is also 4, so that's 13, because it's above the curve. Then f of 6, we could just take f of 2 plus the amount that accumulates from 2 to 6. Okay, so if we're looking at the area from 2 to 6, the area, this is a semicircle with a radius of 2. So the area, right, is 1/2 pi times 2 squared. So that ends up being 2 pi, but since it's below the curve, below the x-axis, and you're going from left to right, that would be a negative integral. So it's -2 pi. Okay, taking a look at example 4, they give us these areas. So this area is 4, okay? This area is 9, this area is 2. And then we're going to graph this. Okay, number 1, the initial condition, f of 3 is 5. So that's about up here somewhere, right? Okay, so we start off, we have, we want to find f of 0. Okay, so we're going to be working backwards. So f of 0 would be f of 3 minus the amount that accumulated from 0 to 3 of f prime dx. So f of 3 is 5, and then the amount that accumulated from 0 to 3 was 4. So this is 1. So I go to 0, and I graph this at 1. Okay, so then the next one, f of 7. So f of 7 would be f of 3 plus the amount that accumulates from time 3 to 7 of f prime dx, because you integrate a rate to get an amount. So we have 5 minus 9, because the integral is -9, even though the area is 9. So this would be at 7, -4. And then we have f of 9. So f of 9 would be f of 7 plus the amount that accumulates from 7 to 9 of f prime dx. So that would be -4 plus 2, which is -2. Okay, so that's f of 9 is negative 2. Now, keep in mind, okay, your function starts off from here to here. Your function is increasing. Your function f. So we're increasing, but if you look at the slopes of the slope, this is the slope graph. So from here to here, the slopes of the slope are positive. So that means it's going to be concave up until you hit 1.5. So 1.5, concave up. And then it switches to concave down, but increasing. Okay, so for the next part, okay, your function is going to be decreasing here, but your slopes of your slope are negative here. So you're still going to be concave down until you hit 5. Okay, so until I hit 5, I'm going to be concave down. Concave down and decreasing. And then it's going to go to concave up. Concave up, but still decreasing. Okay, this doesn't have to be perfect, all right? Just try to make it look good. And then for the last piece, okay, I am going to be increasing throughout here, but I will be, these slopes are positive, so I will be concave up from 7 to 8. So from 7 to 8, I'm concave up, then I'm concave down. All right, and I can just, you know, clean this up a little bit, just to erase a little bit so that it looks a little nicer, a little smoother. Whoa, didn't mean to erase that much. Okay, but you get the idea. You can certainly improve upon this. Okay. Let's make it look more like a curve. It's a little difficult to do the curvature down here. Okay, but you get the idea. It's just a sketch. It's curve sketching. So I don't know how much curve sketching you guys did last year or not. Okay? Okay, just one word problem, then we're done. So we have a pizza with a temperature of 95 degrees Celsius. So that's your initial amount. Put into a 25 degrees Celsius room when the temperature is 0. Okay, the pizza's temperature is decreasing at this rate. Estimate the pizza's temperature when the time is 5 minutes. Okay, we're going to use a calculator for this. So the temperature, all right, so this is the rate. So the actual temperature, so we'll just say, okay, T of 5, well, let's just call it T of 5, is equal to the temperature times 0, which is 95, minus, all right, the amount that it cools down from times 0 to 5. Now, on your calculator, you need to be careful with this E. You need to use the E that's with the ln, no matter what calculator you use. So find ln and look for E, how you access E. Okay, so I'm going to pause this and type this into my calculator and remind me to show you in person how to do that tomorrow. Okay, so I got 95 minus the integral, and I did, I'm using the TI-84 here, and I just did math 9, and it's easy to type this integral in. So I end up getting that the temperature at time 5 is 71.3918. So two answers would be acceptable, 391 or 71.392 degrees Celsius. Okay, that's the end, concludes this video. Thank you.